So a few more trigonometric identities and verifying those. So we have this 1 plus cos x divided by 1 minus cos x, and that's equal to cosecant of x plus cotangent of x quantity squared. All right. So this is a tough one because a lot of students would start on this side. All right. Most of the time we try to start on the left-hand side. But in this one, we should actually start on the right-hand side because cosecant and cotangent are a little more difficult to work with. What I'm going to do is I'm going to start by using the ratio identities, and I'm going to write this as 1 over sine of x, and we know that the cotangent function is going to be cos x over sine of x. So we have cos x over sine x quantity square. All right, so that's just by using our ratio identities. And then what I'm going to do now is add those together, all right, inside the parentheses. So I get 1 plus cos x divided by sine x quantity square, right? So that's just by adding. And now what I can do is I can square both the numerator and the denominator. Okay, so this is going to be 1 plus cos x quantity squared divided by sine square x. All right. So that's just by applying our rules of exponents. Right? Maybe that look like a real sine, the cosine, just because it bothers me. So that's a cosine of x, and this is our sine square of x, okay? And again, that's just by using our exponent rules. And now what we can do is we can go ahead and we can turn sine square of x by using our Pythagorean identity, okay? So you might remember that we have sine square of theta plus cos square of theta equals 1. And if we subtract cosine square from both sides, we get the sine square is equal to 1 minus cos square theta. All right, so don't forget about that those original Pythagorean identities, we can just move things to other sides. Okay, so this is going to be 1 plus cos square theta divided by 1 minus, or I'm sorry, 1, this should be, sorry, I forgot the parentheses there. So this should be 1 plus cos quantity squared of theta, and it should be cos x, excuse me again, right? And this will be our 1 minus cos square of x. All right, so again, that's just by Pythagorean identity. And now, one last thing we can do before we finish this off is we can factor the denominator as a difference of squares. All right, and you probably remember this formula. If you have a squared minus b squared, that's equal to a plus b times a minus b. And so down here, we have 1 minus cos square, and that's going to turn into 1 plus cos x times 1 minus cos of x. And then finally, what we notice is that the numerator and denominator are going to share a common factor. Right? So it's going to be 1 of cos x squared. And I want you to notice that there's a 1 plus cos x and a 1 plus cos x squared in the numerator. So those would cancel out. And so we are left with 1 plus cos x divided by this 1 minus cos x. All right. So again, we factored here, and we just went through and we canceled our common factor. All right. So, and that verifies the proof, because remember, we wanted to look for 1 plus cos divided by 1 minus cos. Okay. All right. So one more example in this video. So we have this cos 1 plus sine plus 1 plus sine x divided by cos, and that's equal to 2 secants of theta. All right. So what we're going to do is we're going to get a least common denominator. Okay. And in this case, the LCD is going to be 1 plus sine of x times the cosine of x. Right? And so what we're going to have to do is, just like we've seen in previous videos, we're going to have to multiply the top and the bottom by whatever the missing component is going to be. All right. So notice over here, we're missing the cosine. So what I'm going to do is, let me rewrite this so we can see it nicely. So we're going to have cos x divided by 1 plus sine x, and then 1 plus sine x divided by cos x. And so notice with the least common denominator, what we're going to do is we're going to multiply this term by cosine of x. Okay, so this is our common denominator. We have the 1 plus sign, but we don't have the cosine of x. All right, so we're going to multiply by cos x over cos x. And then over here, notice that we have the cos x, but we don't have the 1 plus sine x. So I'm going to multiply by 1 plus sine x. Right? And again, that's just by multiplying to get our least common denominator. Right? Now, at this point, let's go ahead and multiply. Okay, so, and by the way, this step, we just multiply to get our least common denominator. Okay, and so if we multiply, cos times cos is going to be cos square of x, and we still have our denominator of cos x 1 plus sine x, and we're not going to FOIL that, we're just going to leave it. Now, in the numerator over here, we're going to FOIL. Okay, so we have we're going to have a 1 times 1, so that's going to be a 1. And we have 1 times sine, so that's going to be a sine of x. Sine times 1 is going to be another sine x. Sine times sine is going to be a cosine. Or I'm sorry, sine times sine is going to be a sine square of x, excuse me. Eventually it will be, right? And then denominator is going to be cos x 1 plus sine x. All right, so again, that's just by multiplying. Now, what we can do is we can combine these, okay, into one just big old fraction. And so, because we have common denominators, so now we have cos square of x plus 1 plus 2 sine of x, right? So I want you to notice that sine plus sine is going to be 2 sines, and then we have a sine squared divided by whatever our common denominator was, which was cos x 1 plus sine of x. Okay, so that's just by adding. Notice that we have a sine square and a cos square, and they're both positive. So that just turns into 1, right? So we have 1 plus 1 plus 2 sine of x divided by cos x 1 plus sine x. Okay, so that's just by Pythagorean identity. Sorry, every time I try to write Pythagorean, it doesn't come out too well. Okay. And now what we can do is we can go ahead and combine the ones. I think that's pretty easy to see. So 1 plus 1 is going to be 2 plus 2 sine of x divided by cos x 1 plus sine x. Okay, so that's just by addition. We can factor out the common 2 that's in the numerator. So 2, 1 plus sine x divided by cos x 1 plus sine x. Right? And now we can clearly see that there's going to be a common 1 plus sine x between the numerator and denominator. Okay, and so what we're going to do is we're going to cancel those out. Okay, that's going to leave us 2 over cosine of x. And then finally, the last thing we can do is we can remember that the cosine is a reciprocal rate identity from secant. Okay, and so this is going to end up being, and I'll fill in the steps in a moment, this will be 2 secant of x. Okay, and so our justifications, we factored here, we canceled, and then finally, we just use our reciprocal identity. Okay, and of course, we go back up and we check, and that's exactly what we needed was 2 secants of x. Okay, all right, so those are two more difficult types of ratio or being able to verify our trigonometric identities. So we have one more video, and similar to that, we're going to go ahead and take a look at some more difficult types as well.